Greetings, everyone. My name is Aaron Smith, and I'm a Strategic Account Manager for TPM in the 3D Printing Division. I have Max Flames with me, who is the Technical Solutions Manager for 3D Printing as well. TPM has partnered with the top organizations in software and hardware in the 3D space in order to bring digital transformation to your company. Today, we're going to be going over some of these solutions are best at and how you might be able to use them at your company. Without further ado, I'm going to turn it over to Max, who's going to talk to you about Artec 3D.
Greetings, everyone. Like Aaron mentioned, TPM represents many different solutions in the manufacturing space. And one of those solutions is Artec 3D scanners. What you see on the slide here is the full line of scanners that TPM represents from Artec. Starting from the left and going to the right, we have the Artec Micro, which specializes in ultra-high precision scans of small objects. Think about the size of a car headlight bulb. The Micro has seen tons of success in everything from jewelry to dental scans. Next up, we have the Space Spider. The Space Spider is a high-precision scanner that specializes in capturing small objects that range from about the size of your ear to the size of a shoebox. The Artec EVA specializes in mid-sized objects such as furniture and the human body. The Leo is the flagship of all the Artec scanners, and not only can it handle smaller scans like the Space Spider, but it can also handle much larger scans like a body panel of a car. It is also wireless. Let's dive deeper into the Artec Micro. The Micro is an automated desktop 3D scanner that can handle all of your high precision needs. It is capable of a scan accuracy of 10 microns, hence the name Artec Micro. Typical applications of the Micro include small electronic connectors, dental scans, jewelry scans, and other small mechanical parts such as watch gears and electronic components. One example of a use of an Artec Micro is to get a very detailed model of an electronic component in which you need to design an enclosure or nest for. The Artec Space Spider got its name quite literally from space. It is used in the International Space Station to reverse engineer parts on the space station on the fly. The Space Spider is capable of a scan accuracy of 50 microns and is typically used in reverse engineering of smaller components that range from a baseball size to about the size of a shoebox. The Space Spider is excellent at reverse engineering plastic injection molded parts and organic shapes. The Artec EVA is an industry favorite scanner which is known for its ultra-fast scans and reliability. The EVA touts a 100 micron accuracy rating, but it makes up for its lesser precision in its portability and its capture speed. If you're reverse engineering components that are cast or net shake components, the EVA may be all you need. The EVA has seen tremendous success in the furniture and casting industries. The Artec Leo is the flagship of all the Artec 3D scanners. It is a portable, handheld 3D scanner which has an accuracy rating of 100 micron. What makes the Leo the flagship of the Artec scanners is the onboard computer on the scanner itself and also its portability. If you have a large equipment that needs to be scanned, the Leo is the scanner for you, as it has a long battery life that will allow you to keep on the move instead of being tethered to a computer. The Leo has seen tremendous success in scanning vehicle interiors and other large industrial equipment. Artec Studio is the next step in the process after scanning. Once you utilize an Artec 3D scanner to capture whatever data you like, the next step is to import the data into Artec Studio for processing. Artec Studio has an extremely intuitive interface and will quickly allow you to create CAD files and meshes of your scans to either be 3D printed or reverse engineered. Artec Studio also has an autopilot mode, which will walk you through the scan registration process all the way to final mesh creation. This autopilot mode is an excellent way to train users to use the software and also to create precise models. The Geomagic suite of software is specifically designed to take your 3D scan files and directly use them for reverse engineering, CAD documentation, and for inspection reports. Software like Geomagic DesignX allows you to take the scan data from your 3D scanner and parametrically design on top of it, while software like Geomagic ControlX allows you to compare your real-world 3D scan file and compare it back to the perfect CAD representation to collect an inspection report. Markforged 3D printers empower engineers and manufacturers to create strong as metal finished parts using the right materials for the job, and remove the multiple barriers between design and production. With a complete line of machines made to create functional parts, Markforged has a solution to meet your manufacturing challenges. Markforged is capable of unparalleled strength when compared to other like 3D printing systems. In the Metal X line of printers, our 17-4 stainless material is able to perform just like regular 17-4 stainless, allowing us to substitute most machine parts to 3D printed parts in the field. In the composite line of printers, our carbon fibers have a better flexural stress and strain of that of a 6000 series aluminum, which allows for incredible weight and cost savings when swapping from machined aluminum to composite 3D printed parts. This is a quick screenshot of Eiger, the slicing software driving the Markforged prints. This arrow is pointing at the printing time for this GoPro mount. The time shows about 4 hours, and since the FFF process is a linear process, if we were to print 2 of these components, the process would take 8 hours, and for 3, it would take 12 hours. This next screenshot shows a detailed internal layout of how we can deposit fibers within the layers of our parts. This screenshot is showing what we call sandwiching. This technique allows us to save on material costs for the fibers while also having the highest strength to weight ratio. Here is a great example of continuous fibers within a printed part. On the left is an isometric view of the part, and on the right is the cross-section of the same part where the fibers have been printed. The fibers are in yellow on the exterior of the part. Let's talk about the Markforged Metal X. The Metal X utilizes a 5-step printing process called ATOM. ATOM stands for Atomic Diffusion Additive Manufacturing. The first step is the design. We will take our CAD file and convert it to an STL file. Then we will send it to the slicing software Eiger. From Eiger, the part will be printed. This print will be very soft to the touch and will have a waxy binder holding the print together. The wash stage will remove this waxy binder from the print. The center stage will center the component and fuse it together into a fully dense metal part. Throughout this 5-step process, Eiger will automatically scale the part larger for the centering process so that when it is centered, it will shrink back down to its original size. Markforged delivers a full range of engineering-grade materials, including plastics, composites, and metals. But that's not all Markforged offers. Let's change gears and now talk about what else Markforged brings to the table that sets it apart from the rest of the crowd. Blacksmith is an add-on available for the X7 platform, which gives you an automated onboard laser inspection tool. As your part is sliced in Eiger, Eiger will also create a laser scan toolpath to follow the contours of your part. In between layers, Eiger will pause and use the onboard laser measurement tool to create a measurement point cloud. Once the print and scans are finished, Eiger will generate a print report that will compare the printed component back to the STL that was provided to Eiger. The measurements that Eiger will provide will compare the STL to the printed part. And the best part about Blacksmith is that Eiger will then use those measurements that were collected to improve the accuracy of the print the next time you need the same part. This is all in an effort to improve the accuracy and quality of your parts every time you print on Markforged. I want to change gears here a little bit and talk about some applications. Dayco is a manufacturer in the automotive industry that spends a lot of its time creating tooling and fixtures for its end-use parts. The traditional manufacturing process utilizes machined aluminum and took about 200 hours and $3,500 in material to create the parts that you see on the screen here. With the parts being designed for Markforged Onyx instead, they were able to create the same tooling in 100 hours, and they only used $1,500 in material. And on top of that, Dayco was able to reduce the inventory costs associated with the parts since they were 3D printed. Fisher Connectors is a manufacturing company in Georgia that creates overmolded connectors for aerospace and defense. For a typical mold tool for an overmolded connector, it takes about 4 weeks of lead time and around $5,000 to create the tooling. By utilizing Markforged Onyx and high-strength, high-temperature inlaid fiberglass, they were able to reduce the lead time to 1 to 2 days and only $150 in tooling. For this specific case, Fisher actually uses this 3D printed mold tooling as their production mold tooling. And here are 3 more examples of how Markforged 3D printing can create savings and reduce cost. Starting from the left and moving to the right, we have a vice grip. The traditional manufacturing process took 3 weeks, and the manufacturing process took only 1 week. This yielded a 75% cost savings. Next, in the middle, we have some assembly fixtures. The traditional manufacturing process took 156 hours, and the Markforged process took only 12 hours. This yielded a 99% cost savings. And last, we have some manufacturing aids. The traditional manufacturing process took 10 days, and the Markforged process took only 3 days. This yielded an 80% cost savings. With Markforged, there is a massive potential for savings in both the time to produce parts and also the cost to manufacture.
3D Systems is one of the oldest and largest players in the 3D printing space. They are well known for their multi-jet printer series, which is more than capable of printing very accurate and very robust parts. The Figure 4 series is one of the fastest 3D printers on the market and is capable of printing in a wide range of materials. 3D Systems SLA printers have a wide variety of materials and print bed sizes, which make it great for prototyping and in-use parts. Last but not least, 3D Systems full-color 3D printers are perfect for full-color replicas and visual aids. The multi-jet 3D printers from 3D Systems are Swiss Army knives in the 3D printing world. They're capable of incredible accuracy and resolution with a large build volume. With 8 unique materials, they are user swappable. There are few projects that you won't be able to address with this machine. The 2500 has a wide variety of applications, from functional testing to jigs and fixtures and electrical connectors. And with access to a wide variety of materials, the application scope is broad. The Figure 4 standalone 3D printer is one of the fastest and most affordable 3D printers there is on the market right now. The speed at which the Figure 4 operates is quite incredible. Depending on the mode that you select, you can print 100 millimeters per hour vertically. One of the greatest assets of the Figure 4 is its ability to adapt to different applications. The Figure 4 has 15 different materials that it can print in, and performing a material swap is incredibly easy. Just empty the fluid back into its container and wash out the metal build platform, and you're ready to introduce another material in liquid form. 3D Systems stereolithography line of printers are in a league of their own. With a max resolution of 4,000 dpi on each printer and maximum final part weights from 21 pounds to 330 pounds, the SLA line of printers from 3D Systems will allow you to make scale prototypes with incredible accuracy. 3D Systems has over 10 different material options for its SLA printers, and paired with large build volumes, the number of applications possible is overwhelming. 3D Systems ColorJet printing, otherwise known as CJP, allows engineers and designers the flexibility to design in full CMYK color. From anatomical models to full color prototypes, the CJP line of printers can get the job done. Applications of the ColorJet range from medical models and industrial design validation models to educational tools and architectural design. The low operating costs and high stability of the CJP process make it easy to continuously print high detail color parts without having to worry about going over your marketing budget. If you've ever wished that you could hold or see a full color print of something you were designing, the ColorJet printers can help. HP's multi-jet fusion line of printers are built with production manufacturing in mind. Capable of incredible speeds that rival injection molding processes, the 4200 and 5200 line of MJF printers are some of the fastest and most robust production printers on the market. Here's an example of a typical layout for our HP MJF 5200 line of printers. Every build that is printed on the 5200 series is printed into a build unit, which can be seen on the bottom left side of the screen. This build unit is moved to and from the printer itself to the processing station and the automatic unpacking station. The typical workflow of a 5200 print starts and ends at the processing station. The natural cooling units for the 5200 allow for full-time 24/7 production, as they allow the build unit to be reintroduced into production immediately after printing.
The greatest part about multi-jet fusion printing is that it is not a linear process. Take, for example, this same GoPro camera bracket from one of the previous slides. If we print one of these, it will take just shy of 3 hours to print. If we fill the XY plane with the same part, it still takes just under 3 hours. This is because HP MJF printing is not a linear print process. Each time the print head on the HP passes over a layer, it deposits material for every spot on that layer. If we fill the entire volume full of the same part, that's when we see the time increase. So for a full build, we have 196 parts, and our print time is just shy of 16 hours.
SmartStream is the software that HP utilizes to create builds and send them to the printer itself. After you import a file into SmartStream, the software analyzes the components and performs any repairs necessary to print the part. After all the components are checked and healed if necessary, you can utilize an automatic packing feature of SmartStream to fully utilize the entire build platform of the printer. In the GoPro example on the previous slide, we made over 100 components in a single build. On this slide, we have a number of different components that are all used within the same assembly. With Multi-Jet Fusion, we had the luxury of utilizing the entire build platform to produce all the parts in the same build regardless of what assembly they belong to. Imagine packing a full assembly, fasteners and all, into a build and starting the print on Friday afternoon, and you'll have the entire assembly printed and waiting for you on Monday morning so you can test fit and function. After the components are packed, all you need to do is select a printer from your list of online printers and send the build out to be printed.
As we all know, one of the greatest features of 3D printing is the design capabilities we unlock when we're able to print things. In industry, this process is called Design for Additive Manufacturing, or DFAM. The slide shown is an example of how DFAM can help improve your design and unlock all of the design capabilities of 3D printing. On the far left-hand side, we have our original machined aluminum part. The first redesign for 3D printing removed a ton of material on the print, resulting in a 60% cost reduction. The next redesign yielded a 93% weight reduction. The last redesign yielded another massive weight reduction while also maintaining all of the needed strength in the part. This is accomplished in a process called topology optimization. If your parts are too large for a print, that's no problem. Utilizing DFAM and 3D printing design software, you can design in splits to your large parts so that they can be assembled after the printed components are done. One example of an industrial application is IAM's robotic arm grip. The arm grip was designed with DFAM in mind and greatly reduced the lead time of the component. It took 5 days to design and print this component versus 3 weeks if you were to traditionally manufacture the part. By lightweighting components, automation assembly lines can be sped up, resulting in an overall increase in efficiency and a reduction in waste. A perfect example of multi-jet fusion technology revolutionizing your process is the Smile Direct Club. For those of you who don't know, Smile Direct Club creates a mold of your teeth that are affordable replacement to braces. They scan your teeth and create essentially what is a progressive mold for your teeth to correct the alignment. They utilize MJF to create the mold negatives, which are then used to thermoform the guard over it to create the mold. Smile Direct operates 24/7 and prints up to 50,000 parts a day, which are totally unique. AMT is leading the charge when it comes to handling and post-processing 3D printed components. AMT's PostPro SF line is a chemical vapor smoothing solution for post-processing thermoplastic 3D printed parts. The PostPro DP line is the ideal solution for washing or shot blasting parts hour after hour, reducing time and cost-intensive operator time in your post-processing chain. AMT's PostPro SF100 is a game-changing chemical vapor smoothing machine made for manufacturers. The PostPro SF100 is for high-volume production with a processing chamber of 100 liters and Industry 4.0 automation. Its compact and ergonomic form takes up less valuable operating space. PostPro SF100 enhances your surfaces, creating beautiful parts with improved mechanical performance. It also seals the surface, enabling easy cleaning, dyeing, and coating while keeping dimensional accuracy without marks from fixtures. PostPro DP Max is a 2-in-1 system that automatically depowders and shot blasts parts. The depowdering machine is designed for maximum efficiency with continuous tumble belt technology for high throughput. The system sits at an ergonomic working height and is front-loading with reversible belt control for automated loading and unloading of parts. The PostPro DP Max can be connected with external manufacturing execution systems and can communicate and integrate with production workflows.
TPM's partnership with the top brands in the 3D industry have allowed us to digitally transform manufacturing and design in the Southeast. If you have any questions about how these solutions may be able to improve your processes, please contact TPM's 3D printing division today. Thank you for attending our segment on 3D printing. We can't wait to hear from you.